I had some really good conversations with the Ever folks and the Fervo folks, and they said, Steve, when you have a 210 degrees Celsius system, we're going to drill to 210. When you have 250, we're going to drill to 250. When you have 300, we're going to go to 300. So that was the moment where John and I realized this is the mission. So we had to figure out, what can we do? As an MWD industry, we've kind of been stuck in the 175 Celsius, 185 Celsius range since the mid 90s when Sperry Sun came out with the first high temperature tools, 175C, 185C systems. We've kind of been stuck there. If we can have a 210 degrees Celsius tool, when you combine insulated drill pipe, when you combine coating, you combine chillers, and God forbid staging in the hole, we think with a 210 degrees Celsius rated system, you can get into rocks that are 250 Celsius, 270 degrees Celsius. And what that does to the LCOE is it reduces it by almost 40, 50%, depending upon who you talk to.
Welcome to Geothermal Unleashed, where we will explore the cutting edge of geothermal energy. I'm Elizabeth Cambre from the Vallourec New Energies team, and I'm here to help educate and document geothermal's rise in the global energy transition. Today, I'm delighted to welcome my guest, Steve Krase, the CEO of Hephae. Steve, welcome to the show today, and I want to get things kicked off by asking you to share a little about yourself. Can you tell us how you came to found Hephae and how you got into the geothermal industry?
Thanks, Elizabeth. It's really a pleasure to be here. I know we've been talking about doing this for a while, and thanks a lot for having me. So yeah, Steve Krase. I've actually been involved in oil and gas actually for 45 years. I grew up in Long Island, New York, which, in case you didn't know, was actually the original center of the oil field. I don't know if you knew that or not, but that's back when it was whale oil. Uh, that was a joke. And anyway, I got a geology degree from University of Akron, 1980, and I thought that I was actually going to ride around the Rocky Mountains on a horse with a hammer, look for gold. Went out there, interviewed for a job at the AAPG convention in Denver, and within 60 days, I was on a rig in the Gulf of Mexico doing mud logging. So started out doing mud logging. I got into petrophysics with Chevron, actually, and then I worked for a company called the Superior Oil Company, which was acquired by Mobil in 1984. And at that time, I had heard about this thing called measurement well drilling, and I just thought it was magic. The concept of being able to get data from downhole while you're drilling without using any wires. You're not being an engineer, being a geologist, I thought this is magic, and I got to be part of it. So I was just really intrigued by the concept of being able to, or the promise of being able to get logging measurements while you're drilling instead of having to wait after the well's drilled and then wait for wireline logs, and you got all this borehole invasion that happens, and you get crummy data. So the promise of getting great data by taking your logs on drill pipe was just magic to me, and I had to be part of it. And I think it ties into the what's happening today in geothermal, because when I left Superior Oil to go work for Teleco up in Connecticut in 1984, everybody thought I was freaking crazy. Because there's like no way you're going to replace neutron density resistivity sonic on LWD. In 1984, that was absolutely crazy. But by 1992, when we were acquired by Baker Hughes, it was a requirement, which is why Baker Hughes actually made the acquisition of Teleco. I worked in operations for a while in technical sales, but and then I became director of engineering at Teleco, carried on in the same role with Baker Hughes, and we developed the first triple combo LWD systems for Baker Hughes. Went over and did the same thing at Halliburton for a couple of years, worked on the stuff that became Pathfinder, and then did a series of startups. And the most recent startup was a company called Navigate Energy Services, which we sold to Neighbors Industries about 12 years ago. There we developed a measurement well drilling system specifically for unconventional oil and gas. And did my time at Neighbors, and then was looking for something else to do. And somebody told me about geothermal. I should look at it. Now, I started actually back at Teleco in the 80s. We used to send all the tools up to the geysers. So all of the MWD tools that are used in the geysers back in the 80s were actually teleco tools, old the original MWD systems. So I thought I knew everything about there was to know about geothermal. But it kind of coincided when I was looking for something to do when those pivot when Project Interspace, those pivot broadcasts started coming out, those webinars, and started listening to those and talking to my co-founder at the time, John Clegg. We were kind of jointly looking for something to do, and we figured out that this next generation geothermal needs the exact same tools that we need for unconventional oil and gas. It just needs to work a heck of a lot hotter, right? And so that's what we've been doing. So we started the company 5 years ago. We've raised about $10 million, $10 million to date to get to where we are. So that was a long answer. So that's where I am.
Another question that I have for you, Steve, is I want to know, where did you get the name Hephae from?
Uh, so when John and I started the company, we thought it was a great idea to call it Vulcan Energy Technology, and we actually incorporated under Vulcan Energy Technology. I think we set up as an LLC in Texas, and we were, congratulating ourselves on, starting a new company and getting a new name. And then we started doing Google searches on Vulcan Energy, and there's like 600 freaking Vulcan Energies out there. And so, oh God, we messed up. So, John being the scholar that he is, he said, wait a minute, for every Roman god, there's a Greek god. And the equivalent of Vulcan in Greek in Greek mythology is Hephaestus. And so we Hephaestus was too long, so we cut it to Hephae. And as John likes to say, we hope he doesn't mind because it sounds like he was a pretty bad guy. So anyway, that's where it came from. So it's pronounced Hephae like chief, but it's short for Hephaestus, the Greek god of blacksmiths and volcanoes and some other stuff.
That's a great answer. I remember those pivot webinars. That was back during COVID. I used to dial into those as well. Well, I was at Baker Hughes. I didn't realize that you worked at Baker. Um, but yeah, they were very interesting, and they definitely sparked my interest in geothermal when I saw those. So very
Yeah,
cool.
yeah. That was actually, I was bouncing back and forth between here and California. So I was dry. I'd have 20 hours in the car, and I would listen to the whole pivot thing, and then I'd call John up. I say, "Hey, man, let me make sure I understand what's happening here." And yeah, we both realized that this is an opportunity. So
Wow. All
that's
right.
how we
Very
that's how we
neat.
got here.
That's very neat. Well, let's turn now to talk about Pandora 210. So this is a major milestone for Hephae. Can you walk us through the development process and what makes this MWD system unique?
Yeah, I think so. It's interesting, Elizabeth, is that when we look at the opportunity here, I think we're going to talk about it more here, and it's all about levelized cost of energy, right? And hotter is better. That's one of our phrases that we use a lot. You also hear not from us, but temperature is king. And so what I've learned from that, actually, it was the first GRC convention that I went to in San Diego, which was also in the middle of COVID, uh, trying to understand, okay, what does the market need? And I had some really good conversations with the Ever folks and the Fervo folks, and they said, Steve, when you have a 210 degrees Celsius system, we're going to drill to 210. When you have 250, we're going to drill to 250. When you have 300, we're going to go to 300. So that was the moment where John and I realized, yeah, this is the mission. So we had to figure out uh, what can we do? Because most, we as an MWD industry, we've kind of been stuck in the 175 Celsius, 185 Celsius range since the mid 90s when Sperry Sun came out with the first high temperature tools, 175C, 185C systems. And we kind of been stuck there. So we talked to our smart electrical engineering guy, Matt White, and told him what we wanted to do. We said we needed to go to 300, and he said, "Let me think about it." And he came back about 2 days later, and he said, "I think we can do 210 degrees Celsius," which doesn't sound like a big deal because there are some 200C systems out there now, but what the it really is a step change. They're going from 200 to 210 Celsius and our ultimate goal of going to 300 degrees Celsius. So it's really a step change in the industry from an electronic standpoint. And that's the key. The mechanical stuff is pretty straightforward with regards to temperature and at the temperatures we're talking about, but it's really the electronics that was the challenge.
Okay, so can we talk a little bit more and we can talk about the electronics, but what are the biggest challenges in drilling at temperatures above 210? And how
Yeah,
did you
that's
overcome this?
we talk to a lot of investors, especially now when you've got there's so much enthusiasm around geothermal. Everybody's trying to understand what's happening here. What does this all mean? And what temperature is enough? Because you have people talking about drilling into magma, and then you have people that are, you have to be careful when you're talking about geothermal. You have to be careful to understand exactly what people are talking about. So we think it has to, you have to be clear that we're talking about circulating temperature. And if you look at the targets of some of the EGS companies that are out there right now, everybody's trying to get into the super hot rock range, um, uh, well above 250 degrees Celsius. And what we've seen with insulated drill pipe and mud chillers and coated drill pipe and staging in the hole, what we're able to do is we're able to manage the circulating temperature. Probably, if you look at somebody that's drilling a 205 degrees Celsius rock formation right now, you can keep the circulating temperature down to 165, 175 Celsius. At least that's what we're seeing. And so we think that if we can have a 210 degrees Celsius tool, when you combine insulated drill pipe, when you combine coating, you combine chillers, and God forbid staging in the hole, we think with a 210 degrees Celsius rated system, you can get into rocks that are 250 Celsius, 270 degrees Celsius. And what that does to the LCOE is it reduces it by almost 40, 50%, depending on who you talk to.
Got it. Okay, so we're going to shift. You've mentioned plans publicly that you're going to be introducing a rotary steerable technology by 2026. So what are the key innovations that you're targeting with that system?
It's really nothing to do with the actual rotary steerable itself. Okay, so most systems today, if you look at a job today that's being run in a lot of cases, I can't. It's not the whole industry, but typically you've got a separate rotary steerable system that's got its own electronics, and then you've got an MWD system above it that has its own electronics, duplicate. Orientation module here, orientation module here, control electronics here, control electronics here. What we decided to do is combine the two. So we have one set of electronics and one control system, and we can put the steering head, the rotary steerable at the bottom, and transmit data at the top. So we have one integrated system that's rated to 210 degrees Celsius that's capable of providing MWD and also capable of steering of driving the rotor steerable system. So I mean, there's some changes to the steering head that we're looking at, but the big change here is one set of electronics rated to temperature that it's one integrated system.
Great. Okay, so next I'm going to ask another question, and I do want to also hear, I'm going to throw in what are going to be the step changes to get to even higher temperatures, but I want you to throw this into the question of when we look at next generation geothermal being the answer to 24/7 carbon-free energy, what role do you see Hephae playing in the scaling geothermal globally? And to do that, I imagine we need to be able to go to the higher temperatures. So what needs to happen to go to temperatures above 210, to the 250s, to the 300s?
Again, I get this a lot from investors because it's a very confusing landscape because you have people that are drilling geothermal wells today and they don't take surveys. They got to drill blind because there are no MWD systems available to get the surveys that you need. So at the end of the day, if you drill a well, whether it's in Indonesia or Philippines, Iceland, a lot of times you have to drill blind because you don't have any way to get a survey. You really don't know where that bottom hole location is. So when you get a well that you've drilled your well now and then you get nothing out of it, the geology guys point to the drillers, and they said, well, you put it in the wrong place. And the drilling guys point to the geologist, well, there was no steam there, or there was no water there, right? So what we've learned in oil and gas is that wellbore placement is critical, especially when you're drilling a horizontal well that you're trying to put into the same two horizontal wells that you're trying to put into the same fracture network, like somebody like Fervo's doing, or if you're trying to connect two wells at a toe, like whatever's doing. So you can't do it without measurement well drilling, and we believe that this market is going to go the same way that unconventional oil and gas is going, and that it's going to be rotary steerable. It's going to be a rotary steerable market, especially when you consider a lot of these reservoirs are in granite and sliding with a drilling motor at 5,000 foot lateral lengths, or we hope to be going to 10,000 foot, 15,000 foot lateral lengths. We believe that the same thing that drove rotary steerable into the unconventional oil and gas space is going to drive the unconventional, the next generation geothermal space. So the answer is wellbore placement is critical. And the only thing that's keeping these customers or these operators from going deeper and hotter and achieving the levelized cost of energy that can compete with natural gas and other things is the ability to steer at temperature. And right now, nobody's drilling at circulating temperatures above 200 degrees Celsius, and that's absolutely critical, especially if you start to talk about super hot rock or supercritical geothermal.
Very interesting. So is there a huge technology gap to be able to go to the higher temperatures? Is there still a lot of work that needs to be done?
It goes back to our approach, and I know you were going to ask me this question at some point here, but I'll just address it now. Is one of the things that I learned from a great engineer at Baker Hughes. His name was Don Wiesenberg. Some of the listeners may remember Don. Um, Man, I learned so much from that guy. And what I learned was that you have to separate research from development, right? So one of the things that our team is really good at is understanding what's research and what's development. So we knocked out the research part first. And so that's why we're so confident that we can do this 210 degrees Celsius system. We've knocked out the research. Now we're in development mode, and we're just building tools that are probably going to work at 215 Celsius. That's what it looks like. But what we believe is that we're kind of, once you start to get above 250 Celsius, that's another set of research. So we feel really good about being able to go to 250 Celsius with the technology that we have and the approach that we have. But to go to 300 degrees Celsius, we're going to need to incorporate some other things. You've seen some of the references that we've had with regards to space. We're hoping to leverage off of some of the things that NASA's doing to put the 500 degrees Celsius rover on Venus, and some other things. But yeah, so we think that getting to the 225, 250 Celsius kind of range is doable for us in the short term. When I say the short term, next 5 years. By 2030, we think we'll have the ability to go to higher than 250 Celsius, and our target is 300 Celsius, which
That's not
many people think is crazy, but it won't be the first time.
right. Right. Well, I think it's really exciting. So Hephae recently raised $4 million to support field trials. So what are the key milestones that you're aiming to hit with the funding with the field trials?
Yeah, thanks. Yeah, so we've raised it's been amazing. It took John and I probably 2 years to get our first money. And we got that first $3 million from EXA, which EXA was very at the time. That's Chris Anderson's climate fund. Chris Anderson is the gentleman that started TED Talks. And then Neighbors filled out that round, and that gave us the ability to prove the electronics. We raised another $4 million round led by Underground Ventures, Torsten Koland, who I think you know. And we were joined in that round he was joined in that round by Future Ventures, Steve Jurvetson's company. Steve is one of the SpaceX founders, and then the Grantham Foundation. They joined. And with that $4 million, we had enough money to actually build the first prototypes, which is what we're about to finish right now. And then we just closed an internal round for $3 million that that is giving us the money to finish the field testing. So we've raised about $10 million to date through, and then we added a VC group called Alpha 8 into this last round here. So with this money, we are we're building 6 tools. And we'll be drilling in just off. We just had a meeting this morning. We'll be drilling in about 4 weeks, and we'll be off and running. So
That's very exciting.
it is,
Okay.
yeah, really exciting. It's yeah, and we considering we just started. Really, we started the company almost 5 years ago, but we didn't get any money for the first 2.5 years. So we've really done this in a couple of years, and we got a great team.
That's awesome. Can you share a little bit more about your collaboration with neighbors and other strategic partners, and how are they supporting you in this grand mission to drill at higher temperatures?
Well, the neighbors has been amazing, and I have good relationship. We have a good relationship there because the Navigate was part of neighbors, and they were really good in terms of helping us get started and making connections for us. Has been amazing, and Guillermo Sierra, who's looking after that for us, Siggy and those guys, they just did a great job for us making connections. And as they've made a lot of investments in the space,
Yeah.
and we're doing our best to collaborate with some of these other entities because although we are focused on the MWD system first. The system that we're working on, the electronics, the control system, the memory, all of that stuff has application in other areas. It's not just drilling. So we think that there's application for this on the completions and the production side. Anybody that needs high temp sensors or high temp electronics for geothermal, we think that we'll have solutions for them. And so I would say Neighbors has really helped us in that mission. And I would also say that it's really interesting. I know you've seen it. This geothermal thing doesn't happen without oil and gas. And
Yeah.
it's the same. It's the same rigs. It's the same directional drilling companies. And so it's a tough time in oil and gas from a cash standpoint. And so we've got some really great relationships with some of the service providers that are really we wouldn't be where we are today in terms of we're going to be drilling in 4 weeks. You just can't do that on your own. And so we've got really good collaboration here, not just with neighbors, but some of the other oil field service companies.
That's great. So I'm gonna ask this question. uh, What does success look like for Hephae in the next 12 to 18 months? And I'm hoping that in 12 to 18 months, we can sit down again and reflect back on this conversation about what you've achieved. But
Yeah.
what does success look like for you?
I think success for the industry is starting to drill horizontal wells. When I say the industry, I'm talking about EGS, right? I mean,
Yeah.
that's what I'm talking about right now. And that's what we're focused on, what's happening in the Western United States. So if we can start to drill 200 degrees Celsius circulating temperature horizontal wells, and we can do it next year. If assuming we're successful, we'll be able to drill the first laterals that have a circulating temperature above 200 degrees Celsius and stay in the ground, right? And that's success in my mind. That's success for Hephae, and it's success for the industry because if we can start to drill 250 degrees Celsius rock, 260 degrees Celsius rock next year, and there's no reason we can't do that, then the levelized cost of electricity becomes extremely attractive. And I think we're looking at an industry that explodes.
Great. So you've got teams in Houston, UK, and Spain. So how do
Yes.
you foster innovation across these different geographies?
I'm blessed that I have a lot of smart guys that 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 like to work with me and John. And so we've got a core group. Some of these guys I've worked with for more than 20 years. So we've got a core group of guys that know how to work together. We know how to leverage off each other. We have different strengths. And so I've got that core group here in Houston, and then and John in the UK. And then we stumbled upon this opportunity in Spain, in the Basque Country, in Bilbao, where it's a very high tech area, very industrialized, very high tech, and and we again we stumbled on it. We got some grant money from the Basque government, which has been really helpful in us getting us started. And what we decided to do is we put our entire design team, mechanical design team, is actually in the Basque Country. And it's worked out amazingly well. And it's really comes down to one thing, and it's we didn't invent this, and we've had other companies that I've worked with, and John and I've worked with, we've experienced the same thing. If you want to do something impossible, go someplace where people don't know it's impossible. Because when John and I first started this, talking about 200 degrees Celsius electronics, everybody thought we were crazy. And you just got to go someplace where people don't realize that you're absolutely out of your mind. and and especially around the electronic side of it. And a big part of getting our electronics to work is the mechanical packaging, right? And that's the big thing. So really to answer your question is I've got a great team of guys and girls, ladies, and we establish the vision, and we make sure people have what they need to do their job, and we let them go. And that's the secret. That's the secret. Maybe it's not a secret, but
Yeah.
that's what I like. That's what I like to do, and it's been amazing. You got to have good people, and then you just what I've seen is that if you provide a clear vision, and I call it mixing Kool-Aid. You mix a good batch of Kool-Aid, get people to drink it, and then you let them go. So, and it's been great. And there's a little bit of travel involved, but we're managing it. So it's been great. We also have two people in Canada as well. So we're probably the most diverse geographically for a small startup. But it's working.
That's great. You know, it's interesting. I hear people at geothermal say all the time that they want to be surrounded by people who don't think that they are, I'm going to use the word crazy for some of the ideas that they have. And I think it's so interesting in the geothermal space. You know, there's a lot of startups that are trying to do things that no one has done before. And it is important that you try to surround yourself with people who can support and believe you and not just say, oh, that can't be done. Um, but yeah, I think that's fascinating.
Yeah,
Good for you.
we are 100% convinced that we don't if it's not it's not a slag on Houston people, or it just there's no way we get to where we are today if we just use guys that were used to oil and gas
Yeah.
design, and I'll show you why. I hopefully this comes out, but I mean basically this is what an electronics assembly looks like in today's MWD systems. You've got electronics PC board that sits in there. It's very flexible. It's shaped like a ruler. And in oil and gas, historically, in some areas like the Gulf of Thailand, we have to worry about temperature, but most cases you don't have to worry about temperature. You worry about shock and vibration, right? So you get the highest temperature components you get, and then you put it in what we used to call Baker Hughes, we used to call it Pookie. And you just put it in the silicone stuff, and you're just trying to protect it from shock and vibration. And if you're just trying to protect it from shock and vibration, you're not worried about temperature, then you can do this. But what we've learned is that of course, you have to worry about the heat coming in from the formation. But what Vallourec is doing, what other companies are doing around insulated drill pipe, coated drill pipe, mud chillers, those different things, we can kind of manage that to some extent, and we've seen that recently with the Fervo announcement, where they drilled into 500 degree Fahrenheit, 550 Fahrenheit formation, and they were able to keep their circulating temperatures down into well below 150 degrees Celsius. And I'm sorry, I can't make the conversion, bouncing back and forth.
No, I can't either.
Yeah. Anyway, so anyway, we figured out that look, the problem here is that it's just like if you're using your cell phone for a long time, it gets hot. And the same thing's happening with these downhole electronics. They're getting hot. And when you encapsulate it within this stuff, there's no place for that heat to go. And it just keeps heating it up and heating it up. And before you know it, you're 40 degrees Celsius above the circulating temperature of the mud. So what we figured out is that the right way to do this is actually not with a long rectangular board, but it's with these circular boards. And so what we do is we just came up with, I mean, this is just crazy, right? And when I first saw this, like, this is nutty. So what we do is instead of having long skinny boards this way, we've got a series of circular boards that we stack like Pringles in a can. And what that does is it's a very short distance from any component on this board out to the outside of this, which a pressure barrel is, and you've got your drilling fluid is going past this. So we've got a cooling system going by these electronics all the time. So this was the secret, and we're convinced this doesn't happen in Houston, right? It's just so crazy. And when you look at the entire system that we have, and I'll send you we'll insert a picture here, I think, that we can show you the assembly that we have, but it's on our website as well. But you can see what we've done. Completely different, completely different.
Cool. Okay, so let me ask this question. What past lessons in downhole technologies have proven the most valuable in building Hephae?
I talked about it early on. It's understanding what's research and what's development. We knocked the research out. We took that first $3 million and we figured out, okay, can we get the electronics to work? Don't design anything else if the electronics aren't going to work if you can't do it. So we did that first, and so that's key. And then the other part of it is, I talk about this a lot. When I first started my career in the '80s, believe it or not, we used to design tools, and the engineering guys would then essentially throw it over the fence to the operations guys and say, okay, go find a customer that's going to break this for us. And that's the way we did it in the '80s, right? And it was in the '90s when I learned about highly accelerated live testing, we call it halt testing. And what that is you try to break your stuff uh, bef- internally, we've not on a customer's well, right? And so in the '90s, the big service companies made a lot of investment in environmental testing labs, and where we do combined heat, shock, and vibration. And not all engineers embrace that, but we embrace that. And so we don't, when we design something, we don't look for the easiest place to run it. We look for the toughest place to run it. And in this case, it's in a facility on the north side of Houston called Dynaqual. It's an independent testing lab. And that's critical to success of any downhole system. You've got to break this stuff. You've got to find the weak links early before you go out to a customer's well and before you build 20 tools and all of a sudden you have a huge retrofit cost, right? So that's what we've done. We have done really extensive, highly accelerated testing at Dynaqual, uh, more than 50% higher than any systems that we've worked on in the past. We've really put it through its paces, and the results have been phenomenal. And so we again we couldn't do it without another example.
Yeah,
Dynaqual they do testing for NASA as well, but mostly oil and gas. But it's just another example of geothermal leveraging off of the oil and gas infrastructure that's in place not just in Houston but around the world.
I love that. Okay, looking ahead to 2030, what's your vision for high temperature geothermal? Where are we going to be? And are there other frontiers like lithium extraction or super hot rock that you're exploring?
Elizabeth, we are solely focused right now on getting the 300. Well, I've got to get these tools on the ground and demonstrate the 210-degree system. But parallel to that, we're full speed ahead at 300 degrees Celsius. Now, it's really interesting because it wasn't that long ago. You could still find people that will tell you you don't need to work on high temperature electronics because we're going to just cool the mud. Okay, that's one thing, but we don't believe that. We think that this market is going a lot higher. We believe that obviously, if you can get supercritical to work, that's amazing, and you're not going to do it without super high temperature electronics. Now, 300 Celsius sounds crazy to most people. It may not be high enough, but by 2030, I'm convinced that we'll have 300 degrees Celsius electronics that are work in not just drilling, but on the completions and production side.
Okay, I'm going to hold you to that. That'll be exciting. All right, my final question for you is what advice would you give to startups or researchers trying to break into the geothermal tech space?
I think the answer to that, my experience was this. I thought I knew what I was talking about, and I didn't. Right. I thought I knew this. I thought I knew geothermal. I've been involved in this for 45 freaking years. I thought I knew what was going on. I didn't know what was going on. And it took me a long, I say me, John and I, it took us a long time to figure it out. And it's a matter of getting all these data points and then trying to put a trend line through what you're hearing, because you're going to hear a lot of crazy stuff. So put the effort in to try to understand what's really happening. You can't talk to one or two people or one or two companies and think that you've got it sorted. It's very confusing. If you're just looking at this now, you've got to really get a lot of data points in, and then you've got to bring in some outside opinions, right? It can't just be. It's very easy to get blinders on and think you're going in the right direction. So I would say that's the most important thing is trying to get your head around the the industry and the space that you're trying to do. Is it low enthalpy? Is it medium? Or is it high? Figure out where you are and what you're trying to attack, because it's significantly different depending upon what you're talking about, and it can be extremely confusing. And I see it every week with investors that come to me. I say investors and other developers that come to me with uh, crazy questions and just trying to understand what's happening, because it is very confusing. So I think it's navigating this landscape of just crazy stuff. I mean, I say crazy. It's just a lot of it's great, but a lot of it is crazy. And yeah, it's really easy to go out of bounds. But the good news is, if you are looking to get this going, man, there's a lot of interested investors, and it's more and more every week. That's my observation. We're getting many more calls than we did even last year. So
That's exciting to hear. Well,
it
that's
is
great
very,
advice as
it's great.
well.
Yeah, it's great.
Steve, I want to thank you for joining me today on this episode of Geothermal Unleashed. I hope today's discussion has sparked new insights and deepened everyone's understanding of the geothermal industry's incredible potential. Until next time, keep pushing the boundaries of what's possible, and let's continue working together to unleash the full potential of geothermal. Thank you.
Thank you, Elizabeth.